Hi guys, this is Mrs. Louderback, and I'm going to go over how to draw single covalent bonds. So when atoms of nonmetals bond to each other, they share valence electrons and form a covalent bond. When atoms bond, they usually have to rearrange their electrons from the positions we typically draw for Lewis structure. The goal is that every atom to have 8 electrons around it with the exception of hydrogen, which goal is to have 2. Just a reminder, that's the octet rule that we're trying to establish in order to be stable. Now, hydrogen is only going to form a single bond, but the other atoms can form up to 4 bonds. We're going to be drawing Lewis structures in this video to help us work through it. And then there's a little hint to look at, okay? And a little typo here. But carbon, nitrogen, and sulfur are usually the central atoms, which means that they're going to be in the center of our Lewis structures, surrounded by terminal atoms, which can only bond once. Like hydrogen, for example, only has 1 electron, so it can only form 1 bond. All right, to start with, we're going to look at nitrogen triiodide. Now, nitrogen, if I look at my periodic table, is in group 5A. So that means it has 5 valence electrons. So I'm going to draw my nitrogen here, the symbol, and it's 5 valence electrons. Notice it's got 3 locations here to form a bond. It's these 3 locations that I'm going to put my iodine. And if I look, there's a subscript 3 underneath the iodine. Those are going to be where each iodine is going to be placed. So I'm going to put an iodine here, and an iodine over here. Now, iodine is in group 7A. So VII, Roman numeral 7A. So that means it has 7 valence electrons. So I'm going to put 7 electrons around the iodine. And I'm going to make sure to put the 7th next to the single nitrogen electron, because that's where the bond will take place. So I've got 1, 2, switch out pens to make it a little easier. 1, 2, 3, 4, 5, 6, and here's my 7th. 1, 2, 3, 4, 5, 6, and again, I'm putting the 7th next to the single nitrogen. That's where the bond will be. 1, 2, 3, 4, 5, 6, and 7. All right, now I'm going to circle which electrons are going to be forming the bond. So this is going to form a bond, this will form a bond, and this one will form a bond. So in my final answer box, I'm going to clean up this by replacing these electrons that we circled to have a line, and each line will represent 2 electrons. So my nitrogen with the line to show a bond took place, and then the iodine Now it's important to put those electrons that were not in a bond for iodine around to double check our work later. All right, so remember, the goal is for every atom to have 8 electrons around it. We call that the octet rule. So I can double check my work by counting the number of electrons around each atom to see if it meets that octet rule, the rule of 8. So in this atom of iodine, I have 1, 2, 3, 4, 5, 6, and again, the line means 2, 7, 8. Same with this iodine, 1, 2, 3, 4, 5, 6. The line counts as 2, 7, and 8. In the third iodine, 1, 2, 3, 4, 5, 6, and then here's the line, 7, 8. I even want to double check my nitrogen, my central atom, to make sure that it is stable and it is filled. 1, 2, 3, 4, 5, 6, 7, and 8. So that one is complete. So now, let's look at the next problem. Carbon tetrabromide. I'm going to look to see where carbon is on the periodic table. Carbon is in group IV or 4, Roman numeral 4. So it's going to have 4 valence electrons. I'm going to switch out colors here. So I'm going to have carbon with 4 valence electrons. Tetrabromide. Bromine is again, it is in group 7, VII, Roman numeral 7. So it'll have 7 valence electrons around it. So 1, 2, 3, 4, 5, 6. And I'm going to make sure that 7th electron is next to that single carbon electron. And I'm going to do this 4 times according to that subscript 4. So BR, 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. I didn't leave much room over here. Talk about placement, but I've got it right there. Okay, so where that bond takes place. Here's 1 bond, 2, 3, and 4. Now this is why we practice on this side. Okay, obviously I didn't make it very clear over here. Didn't leave enough spacing. So when I do my final answer, I'm going to make sure I make it a little bit more compact so I can see all those bromines. So I'm going to make my carbon a little smaller. And again, each of these 2 electrons that we circled, we're going to replace with a line to show that a bond has taken place between the carbon and the bromine. And each line represents 2 electrons. Then here's my bromine. Okay, double check your work. Carbon, 1, 2, 3, 4, 5, 6, 7, 8. Bromine. Notice, I only have 2 here. I need to go back and I need to make sure I add all of these electrons around my atom because it's also trying to meet that rule of 8. Okay, so 1, 2, 3, 4, 5, 6, and again a minus 2, 7, 8. So I need to make sure I show those valence electrons, every one, especially when we're learning. All right, so now we have a complete model of carbon tetrabromide. All right, let's do one more together, and then the rest you'll do on your own. So here we have dihydrogen monosulfide. And it can be a little bit challenging in terms of when I'm reading this, which element should I go first? Should I do the hydrogen first or the sulfur? I just want to review that we had a hint earlier on top of the paper as far as which element should go first. Hydrogen only has 1 valence electron, so it's only going to have 1 location to bond. Sulfur actually ends up having more locations to bond. So we're going to start with the sulfur first when we draw. So I'm going to put my sulfur in the center. Okay, and sulfur, if I look it up, sulfur is in group 6A, VIA, so that's 6. So it has 6 valence electrons. 1, 2, 3, 4, 5, and 6. So these are already paired up, so I'm not going to worry about them. It's these 2 that don't have a pair. That's where the hydrogen is going to go. So I'm going to place my hydrogen, and I have a subscript 2. I have a subscript 2, so that's where the hydrogen, I'm going to have 2 hydrogens. Tells me how many I need. So I've got 2 hydrogens here next to each lonely little sulfur. Here's where the bond will take place. Then over to the side, I'm going to clean it up. And I'm going to replace those that I circled with a line that shows a bond took place and it represents 2 electrons. And again, I can double check my work by seeing that all atoms meet the octet rule. So sulfur does 1, 2, 3, 4, the line 5, 6, 7, 8. Hydrogen only has 2, and again, that's one of those exceptions. Its goal is to look like helium, so it's only going to have 2 electrons to be filled. All right, good luck with the rest of your problems.